Alright, welcome. In this video I'm going to show you how to do tacheometry, stadia tacheometry to be more specific. There's three types. There's stadia, subtense, and tangential. Tacheometry, sometimes you'll see it's called tachometry. Tach just means measure. Alright, so let's get started with this stadia tacheometry. Alright, so stadia tacheometry, you'll see it if you're looking down your builder's level. You get a level line, you have a pole over here. You could be shooting elevation too, differential leveling, and then get your elevation. So it's called 3-wire, and you're going to get the top and the bottom too. So there's a crosshair, and if you look down your telescope, it looks sort of like this. You got your crosshairs go end to end, and on the top and bottom you'll have partial lines. They won't be going all the way to the end. These are called stadia hairs. Stadia, I think it means 100 somehow, or I think it look at old Roman or whatever you got, but it's the difference here. Let's say you're shooting your pole. Let's see what color would be good for about orange. You get a prism pole here. You got your markings on there. And the ratio of this stadia hairs is 1 to 100. So if this is 1 foot, the distance from the pole, from here to that pole, would be 100 feet. So right here, let's say we had from the top stadia hair to the bottom stadia hair, we had 3 foot. Let's go to decimals. 3 point, because it would work for feet and inches or metric. It'd be, let's say you have 3.4. You would have the distance between here and the center of your builder's level or transit would be 340. Could be feet or meters, whatever you got, right? That's how that works. So it's a direct ratio, almost really directly. You just multiply whatever the distance is between the top and bottom by 100. So top minus bottom. You subtract the top from the bottom from the top, and then multiply it by 100, and that equals the horizontal distance. This would be horizontal. Real simple. That's what those stadia hairs do. So let's clean that up, and then we'll do a quick one on tangential, subtense. So subtense method, you have a tripod, almost like a tribrac, but it's on the top of the tripod. You have a subtense bar. And it's right in the center. It's over a point. The face of the subtense bar is directly over the point, right under the center. So you kind of set it up with the triback, and then that locks in, and it's directly above that point. And then you're down here. Let's say you're at a different elevation, and you're shooting up. You're going to shoot the right hand side and the left hand side, and we're looking for this included angle, the difference between the right and the left. You take a shot to the right and left, you'll get your difference in degrees. And then this is sort of the same thing as what we just did before. Maybe I didn't explain it on the other one, but you got 2 triangles, right? This is, say that's 6 feet or 1 meter, and you got 2 triangles that look like this. Even though it's inclined, it's going uphill, right? We've done a vertical angle too. This is a 3, and that's also 3. And what we're looking for is this, right? So this dimension here will be the diagonal. That's what we're looking for, right there. Diagonal. So we have 3. And then the formula goes 3 over x is equal to tangent of delta divided by 2. So what we're looking for, if this was 4 degrees, that'd be 2. So we would just say 2 degrees. Alright, so then we just take this, move the x to the top, you get x is equal to 3 over tangent of 2 degrees. Then you do the mathematics there, and you would end up with calculator. So we go 3 divided by 2 tangent equals 85.91. So 85.91. And then let's check that. So go 3 over 85.91, arctangent of that. Let's just check that. 3 divided by 85.91 equals, and then second function tangent. I think I did it twice. 1.99, so it's 2. So it's 2 degrees. It's just I didn't carry out the decimal. So that's how it works. There we go. Whiteboard. So that closes out. We got that the 2 degrees that we were looking for, and then 4 degrees, multiplied it by 2. So now that we did that, so now we have this diagonal distance, right, from here to here, because we're going to multiply that by 100, right? Or no, we don't have to do any of that. 3 over x, and it just gives us the straight up. It was 85. And then we did, I think, in the previous video before it got blown up and it didn't record. You have to record. So there's 3 things you do. You record V, vertical angle, record top and bottom, record right and left. That would be equal your difference in angle, this one here. And then you got to divide it by 2. We did that. And then like we said, we had the V, the vertical line, so we have the diagonal. And we're looking for the horizontal, or let's say call it H. So H over diagonal 85.91 is equal to cosine of the vertical angle. Right? And then you just go H is equal to cosine of the vertical angle times 85.91. And then you would have H. That's how you'd solve for H. And then this one you could use the Pythagorean theorem. You could use this vertical, let's call, I think I used V already for vertical angle. Let's call this Y. So you would say Y over 85.91 is equal to the vertical angle, sine of the vertical angle. Right? So you'd have Y is equal to sine of V in degrees, vertical angle, sine of vertical angle in degrees, times 85.91. And if you plug this into Excel, you're going to want to say sine of, you would say sine of V, whatever the angle is, you have to say sine radians vertical angle close, and that would give you back the sine of that. Like this one's pretty simple. I think we just did it in sine. So we could say, let's just actually put the numbers in and see what those are. And then let's say that V was 30. degrees. So let's just solve them for both. Calculator, clear. You're going to go sine of 30 tan sine times 85.91 equals 42.95, 42.96. And then the cosine, same thing as just using the cosine. We're going to multiply cosine, so 30 cosine times what was it, 85.91. $74.4. So we would go 42.96 divided by 76 would give us the arctangent. Close that out and get the 2.96 divided by 74.4 equals, then we want second function tangent, 30 degrees. Tangential tacheometry. And then, yeah, there you go. And then the other one we'll put it here was h. It was equal to cosine of 30 times 85.91. And this one here, y was equal to sine 30 times 85.91. And we got 85.91 was 3 over x is equal to sine, so yes, tangent of, we said this was 4, so that was 2. So 2 tangent of 2, because we're just working with that one triangle. And then we would say, so that would cancel, we get 3 over tangent of 2 is equal to x. Let's call it diagonal. So let's do that one more time. So 3 over tangent of 2, 3 divided by 2 tangent equals 85.91. So that's how we got the diagonal. And that was how we got that diagonal, was this one here. All right? And then this was become 80, and then we did all the calculations for that. And that was how you put it into Excel. If you just wanted the sine of an angle. And that's how it goes. So that's what I know about tangential just plain out tacheometry. There's another one, movable hair tacheometry, but I don't know anything about it. All right, I hope that helps in your career, and thanks for watching.